Unicode is a computing industry standard for the consistent encoding, representation, and handling of text expressed in most of the world's writing systems. Developed in conjunction with the Universal Coded Character Set Standard and published as the Unicode Standard, the latest version of Unicode contains a repertoire of more than 120,000 characters covering 129 modern and historic scripts, as well as multiple symbol sets. The standard consists of a set of code charts for visual reference, an encoding method and set of standard character encodings, a set of reference data files, and a number of related items, such as character properties, rules for normalization, decomposition, collation, rendering, and bidirectional display order. As of June 2015 update, the most recent version is Unicode 8.0. The standard is maintained by the Unicode Consortium. Unicode's success at unifying character sets has led to its widespread and predominant use in the internationalization and localization of computer software. The standard has been implemented in many recent technologies, including modern operating systems, XML, the Java programming language, and the Microsoft .NET framework. Unicode can be implemented by different character encodings. The most commonly used encodings are UTF-8, UTF-16 and the now obsolete UCS2. UTF-8 uses 1 byte for any ASCII character, all of which have the same code values in both UTF-8 and ASCII encoding, and up to 4 bytes for other characters. UCS2 uses a 16-bit code unit for each character, but cannot encode every character in the current Unicode standard. UTF-16 extends UCS2, using one 16-bit unit for the characters that were representable in UCS2 and two 16-bit units to handle each of the additional characters. Origin and development. Unicode has the explicit aim of transcending the limitations of traditional character encodings, such as those defined by the ISO 8859 standard, which find wide usage in various countries of the world but remain largely incompatible with each other. Many traditional character encodings share a common problem in that they allow bilingual computer processing, but not multilingual computer processing. Unicode, in intent, encodes the underlying characters, graphemes and grapheme-like units, rather than the variant glyphs for such characters. In the case of Chinese characters, this sometimes leads to controversies over distinguishing the underlying character from its variant glyphs. In text processing, Unicode takes the role of providing a unique code point, a number, not a glyph, for each character. In other words, Unicode represents a character in an abstract way and leaves the visual rendering to other software, such as a web browser or word processor. This simple aim becomes complicated, however, because of concessions made by Unicode's designers in the hope of encouraging a more rapid adoption of Unicode. The first 256 code points were made identical to the content of ISO 8859-1 so as to make it trivial to convert existing Western text. Many essentially identical characters were encoded multiple times at different code points to preserve distinctions used by legacy encodings and, therefore, allow conversion from those encodings to Unicode without losing any information. For example, the full-width forms section of code points encompasses a full Latin alphabet that is separate from the main Latin alphabet section. In Chinese, Japanese, and Korean fonts, these characters are rendered at the same width as CJK ideographs, rather than at half the width. For other examples, see duplicate characters in Unicode. History. The origins of Unicode date to 1987, when Joe Becker from Xerox and Lee Collins and Mark Davis from Apple started investigating the practicalities of creating a universal character set. He explained that the name Unicode is intended to suggest a unique, unified, universal encoding. In this document, entitled Unicode 88, Becker outlined a 16-bit character model. Unicode is intended to address the need for a workable, reliable world text encoding. Unicode could be roughly described as wide-body ASCII that has been stretched to 16 bits to encompass the characters of all the world's living languages. In a properly engineered design, 16 bits per character are more than sufficient for this purpose. His original 16-bit design was based on the assumption that only those scripts and characters in modern use would need to be encoded. Unicode gives higher priority to ensuring utility for the future than to preserving past antiquities. Unicode aims in the first instance at the characters published in modern texts, whose number is undoubtedly far below 214 equals 16,384. Beyond those modern use characters, all others may be defined to be obsolete or rare. These are better candidates for private use registration than for congesting the public list of generally useful Unicodes. In early 1989, the Unicode Working Group expanded to include Ken Whistler and Mike Kernaghan of Metaphor, Karen Smith Yoshimura and Joan Ali Prandavar LG, and Glenn Wright of Sun Microsystems. And in 1990 Michelle Swenyard and Asmus Freytag from Microsoft and Rick McGowan of Next joined the group. By the end of 1990, most of the work on mapping existing character encoding standards had been completed, and a final review draft of Unicode was ready. The Unicode Consortium was incorporated on January 3, 1991, in California, and in October 1991, the first volume of the Unicode standard was published. The second volume, covering hanidiagraphs, was published in June 1992. In 1996, a surrogate character mechanism was implemented in Unicode 2.0, so that Unicode was no longer restricted to 16 bits. This increased the Unicode code space to over 1 million code points, which allowed for the encoding of many historic scripts and thousands of rarely used or obsolete characters that had not been anticipated as needing encoding. Among the characters not originally intended for Unicode are rarely used Kanji or Chinese characters, many of which are part of personal and place names, making them rarely used, but much more essential than envisioned in the original architecture of Unicode. Architecture and terminology. Unicode defines a code space of 1,114,112 code points in the range 0 hex to 10 FFFFHEX. Normally a Unicode code point is referred to by writing U+ followed by its hexadecimal number. For code points in the basic multilingual plane, 4 digits are used. For code points outside the BMP, 5 or 6 digits are used, as required. Code point planes and blocks. The Unicode code space is divided into 17 planes, number 0 to 16. All code points in the BMP are accessed as a single code unit in UTF-16 encoding and can be encoded in 1, 2 or 3 bytes in UTF-8. Code points in planes 1 through 16 are accessed as surrogate pairs in UTF-16 and encoded in 4 bytes in UTF-8. Within each plane, characters are allocated within named blocks of related characters. Although blocks are an arbitrary size, they are always a multiple of 16 code points and often a multiple of 128 code points. Characters required for a given script may be spread out over several different blocks. Character general category. Each code point has a single general category property. The major categories are letter, mark, number, punctuation, symbol, separator, and other. Within these categories, there are subdivisions. The general category is not useful for every use, since legacy encodings have used multiple characteristics per single code point, e.g., U plus 000A less than control 000A greater than. Line feed in ASCII is both a control and a formatting separator. In Unicode, the general category is other control. Often, other properties must be used to specify the characteristics and behavior of a code point. The possible general categories are code points in the range U plus D800 U plus DBFF are known as high surrogate code points, and code points in the range U plus DC00 U plus DFFF are known as low surrogate code points. A high surrogate code point followed by a low surrogate code point together form a surrogate pair used in UTF-16 to represent 1,048,576 code points. Outside BMP, high and low surrogate code points are not valid by themselves. Thus the range of code points that are available for use as characters is U plus 0000 U plus D7FF and U plus E000 U plus 10FFFF. The value of these code points is sometimes referred to as the character's scalar value. Certain non-character code points are guaranteed never to be used for encoding characters, although applications may make use of these code points internally if they wish. There are 66 non-characters, U plus FDDO, U plus FDEF, and any code point ending in the value FFFE or FFFF. The set of non-characters is stable, and no new non-characters will ever be defined. Reserved code points are those code points which are available for use as encoded characters, but are not yet defined as characters by Unicode. Private use code points are considered to be assigned characters, but they have no interpretation specified by the Unicode standard, so any interchange of such characters requires an agreement between sender and receiver on their interpretation. There are three private use areas in the Unicode code space. Private use area, U plus E000 U plus F8FF. Supplementary private use area A, U plus F0000 U plus FFFFD. Supplementary private use area B, U plus 100000 U plus 10FFFD. Graphic characters are characters defined by Unicode to have a particular semantic, and either have a visible glyph shape or represent a visible space. As of Unicode 8.0, there are 120,520 graphic characters. Format characters are characters that do not have a visible appearance, but may have an effect on the appearance or behavior of neighboring characters. For example, U plus 200C0 width non-joiner and U plus 200D0 width joiner may be used to change the default shaping behavior of adjacent characters. There are 152 format characters in Unicode 8.0. 65 code points are reserved as control codes, and correspond to the CO and C1 control codes defined in ISO, IEC 6429. Of these, U plus 0009, U plus 000A, and U plus 000D are widely used in Unicode encoded texts. Graphic characters, format characters, control code characters, and private use characters are known collectively as assigned characters. Abstract characters. The set of graphic and format characters defined by Unicode does not correspond directly to the repertoire of abstract characters that is representable under Unicode. Unicode encodes characters by associating an abstract character with a particular code point. However, not all abstract characters are encoded as a single Unicode character, and some abstract characters may be represented in Unicode by a sequence of two or more characters. For example, a Latin small letter I with an ogonek, a dot above, and an acute accent, which is required in Lithuanian, is represented by the character sequence U plus 012F, U plus 0307, U plus 0301. Unicode maintains a list of uniquely named character sequences for abstract characters that are not directly encoded in Unicode. All graphic, format, and private use characters have a unique and immutable name by which they may be identified. This immutability has been guaranteed since Unicode version 2.0 by the name stability policy. In cases where the name is seriously defective and misleading, or has a serious typographical error, a formal alias may be defined, and applications are encouraged to use the formal alias in place of the official character name. For example, U plus A15 Yi syllable Wu has the formal alias Yi syllable iteration mark, and U plus Fe18 presentation form for vertical right white lenticular bracket has the formal alias presentation form for vertical right white lenticular bracket. Unicode Consortium. The Unicode Consortium is a non-profit organization that coordinates Unicode's development. Full members include most of the main computer software and hardware companies with any interest in text processing standards, including Adobe Systems, Apple, Google, IBM, Microsoft, Oracle Corporation, Yahoo, and the Ministry of Endowments and Religious Affairs of Sultanate of Oman. The consortium has the ambitious goal of eventually replacing existing character encoding schemes with Unicode and its standard Unicode transformation format schemes. As many of the existing schemes are limited in size and scope and are incompatible with multilingual environments, Unicode is developed in conjunction with the International Organization for Standardization and shares the character repertoire with IEC 10646, the Universal Character Set. Unicode and IEC 10646 function equivalently as character encodings, but the Unicode standard contains much more information for implementers, covering, in-depth, topics such as bitwise encoding, collation and rendering. The Unicode standard enumerates a multitude of character properties, including those needed for supporting bidirectional text. The two standards do use slightly different terminology. The consortium first published the Unicode standard in 1991 and continues to develop standards based on that original work. The latest version of the standard, Unicode 8.0, was released in June 2015 and is available from the consortium's website. The last of the major versions to be published in book form was Unicode 5.0, but since Unicode 6.0 the full text of the standard is no longer being published in book form. In 2012, however, it was announced that only the core specification for Unicode version 6.1 would be made available as a 692-page print-on-demand paperback. Unlike the previous major version printings of the standard, the print-on-demand core specification does not include any code charts or standard annexes, but the entire standard, including the core specification, will still remain freely available on the Unicode website. Thus far the following major and minor versions of the Unicode standard have been published. Update versions, which do not include any changes to character repertoire, are signified by the third number and are omitted in the table below. The number of characters listed for each version of Unicode is the total number of graphic, format and control characters. Scripts covered. Unicode covers almost all scripts in current use today. A total of 129 scripts are included in the latest version of Unicode, although there are still scripts that are not yet encoded, particularly those mainly used in historical, liturgical, and academic contexts. Further additions of characters to the already encoded scripts, as well as symbols, in particular for mathematics and music, also occur. The Unicode Roadmap Committee maintain a list of scripts that are candidates or potential candidates for encoding and their tentative code block assignments on the Unicode Roadmap page of the Unicode Consortium website. For some scripts on the roadmap, such as Jurchen, Nushu, and Tanget, encoding proposals have been made and they are working their way through the approval process. For other scripts, such as Mayan and Romno, no proposal has yet been made, and they await agreement on character repertoire and other details from the user communities involved. Some modern invented scripts which have not yet been included in Unicode or which do not qualify for inclusion in Unicode due to lack of real-world use are listed in the conscript Unicode registry, along with unofficial but widely used private use area code assignments. There is also a medieval Unicode font initiative focused on special Latin medieval characters. Part of these proposals have been already included into Unicode. The Script Encoding Initiative, a project run by Deborah Anderson at the University of California, Berkeley, was founded in 2002 with the goal of funding proposals for scripts not yet encoded in the standard. The project has become a major source of proposed additions to the standard in recent years.